So we'll start off just by a quick resume for those of you who weren't there of what was being talked about in that data centre costing workshop, and a little bit of discussion around that maybe. So Steve, who's the best person just to do a quick 1 minute summary of points that are coming up?
Well, I guess the main takeaway is that it's not as easy as it looks. There's a lot of challenges you have to overcome. You want to get the right information to be able to present that in a way that helps you to make decisions in the future, or even in the present. There's actually quite a lot of work you need to do up front, and sometimes what you think you've been spending your money wisely, and you find out that actually you haven't, but you didn't know it until you.
Example.
Well, we talked about PDUs, for instance.
What?
PDUs, the power distribution units that are in the cabinets. Where, when all else fails, if you want to get your power and cost what it costs to run that particular service from a PDU using the power that's in the back of the cabinet, you may find that actually the information you get from that isn't particularly useful. And if you'd spent a little bit more, actually quite a bit more, because getting the right kind of PDU will give you a much better insight into what's going on, then you could actually just save yourself a lot of trouble up front and a lot of cost up front. Just trying to do it all retrospectively is actually but there is, I think that it is possible to get that information. It's just, you need to plan it carefully, and then you need to manage it carefully as well, because ongoing, your operational and maturity can define whether or not that information makes any sense at the end of the day. If your people are allowed to go around changing things and you don't keep abreast of what they changed, then you could be reporting the wrong information.
And what you're partly talking about, I only heard half of it, but as I understand it, is you've now got some quite sophisticated monitoring software in place that's monitoring not just energy but other stuff as well.
And you need to go off and do that stuff as well. Sometimes you have a question, you say, I just want to see this, and it ends up that you have to, in order to see that, you need to see this, and this as well, because they're all part of the equation that gets you to that final figure. But the software you have needs to be flexible enough. Unfortunately, the software that we've got is flexible enough to do that.
The discussion we were just having in this room here, briefly, was just very roughly, the percentage of your data centre operating costs that are going, to the overhead element in the PUE, to the energy and cooling and power supply costs, etc. I quoted some Amazon figures of about 33%, I think. Danny was saying that ULCC thinks it's about 25 to 30% of their total operating costs. You have a figure yourself for half, so about the data?
Yeah, we're getting around 1.2 annualised.
So that's the energy, but
that's 20% facility costs versus the IT costs.
But then are you taking into account the depreciation, etc., and the power supply, which averages
depreciation? No.
That was twice as high as the energy costs.
No, and the reason we don't do that is because we specifically wanted to know the cost of living the service, not the other stuff. We would assume that we would plug into, say, Heidi's model, because she's got a line that says she doesn't know how to apportion the power costs, and we can plug into that line and use the rest of her figures if we wanted to get a full service costing.
Yeah. So can you apportion that between servers and therefore between services?
Yes.
One interesting question, segueing into one part of this issue of how do you allocate costs across the network, the costs like network, etc. One of the answers to that question is that you use a proxy that just gives some rough sense of the distribution of costs between different activities. You say, well, what is that proxy? Now, for things like track, of course, it tends to be floor area per square metre, but potentially energy is another proxy, not just for energy, but for a lot of those overhead costs. I mean, I would add that
the minimum you should be doing is looking at the efficiency of the servers in delivering a service. Because what we found at a number of universities and also commercial customers is that average CPU utilization is very, very low. I mean, that's something you touched upon in your talk. I mean, typically it's below 5%. So you've got a big data center full of IT equipment that's spending most of its time doing nothing. And very few places have a handle on that. And PUE is all relative to that. Yeah. If you're cooling overhead, it's all relative to what you need to run your IT equipment. So if you need a tenth of the IT equipment, you need a tenth of the cooling, a tenth of the infrastructure, you might not need a new data center, you might not need to do anything in your existing data center. So, it's a false economy not to look at simple things like IT utilization. We talk about service costing in the next room, like this was a particular shared application that Steve was looking at. I was talking about things like emails per watt, HTML transactions per watt, things. And that's actually quite an extreme example of service delivery costs. But actually, there's much simpler proxies out there that are valuable. Normalized CPU utilization per watt is a very useful parameter to look at. And if you can see that across the data center, you can see it between different servers, you can get an idea of much better handle on how efficient your data center is. I would suggest that a lot of data centers, if you put HPC aside, a lot of university data centers are probably a lot less efficient at delivering IT cycles than they claim to be.
Why would you put the HPC aside?
Because HPC utilization is generally very high. Now that depends on how good your HPC group is and how good your science.
That's why I asked the question. I think if you take it across the sector, it's a dangerous model to put that aside because energy cost-wise, HPCs are phenomenally energy hungry.
So I'm not, I'm an ex-HPC guy, but if it's used well, it's used up in the 80-90% efficiency. Now, on the HPC side, and this is true across everything, but I know of large HPC systems at various universities around the UK that are 3 to 4 years old. And they're not being replaced because no one's got budget to replace. Now, that is very short-sighted because the cost of running a 3 to 4 year old server and the supporting infrastructure is significantly higher than replacing that whole system. And often those decisions are made without any data whatsoever.
That's kind of why I asked the question in terms of putting that aside. Or I think maybe separate reporting is maybe what we got putting that aside.
So again, something I mentioned, one of the things our tool does is looks at the OPEX and CAPEX costs and tries to point out, you should be replacing these servers because sweating the servers are really bad. Sweating the assets of servers is a really poor idea. It's obviously if you're an FD, you don't think about that in Canada. Not criticising FDs, but no one presents the information to the FD to be able to say, actually, now I understand why you want to swap the system out.
Yeah, it's really key point is actually be able to articulate how much you're using it versus how much it's costing you to run it and actually running those numbers and saying.
Okay.
Yeah,
so when I said CPU utilization per watt, that's rather a simplification because CPU utilization depends on how good the CPU is at doing the task. So what you can do is look at CPU utilization multiplied by a factor, some benchmark figure for that CPU per watt. And then if you look at that across your estate, you'll be able to see which systems are delivering, certainly from an OPEX point of view, good value for money. From a CAPEX point of view, then you need to put in your model, your depreciation model for capital expenditure, and you can get information. But without the information, everyone is making decisions in the void, and sometimes making the wrong decisions.
And actually, there's, I think in the past, as data center managers make the assumption that their data center is going to grow, and they continue to grow, and therefore they need to either look at going out to the cloud or building a new data center or expanding the existing data center they've got. And actually what we found through this project and generally is that the bottleneck is not in the processor anymore, okay, because there's such performant systems out there now that if you, as Michael says, you replace an existing server with the newest model, you'll find your application doesn't get anywhere near stretching it. Okay, that the bottleneck comes in the network and comes in the storage. So it's the I/O that becomes the bottleneck. And what the implications that has for your data center is that you need less bits of tin, because if you virtualize a lot of your servers, you'll find that your estate shrinks, it doesn't grow. And so we were projecting that, saying 5 years' time we might need a new, bigger data centre. And actually I'm revising that down now. I don't think we need a bigger data centre. I think, if anything, we just need to make the best of what we've got, and much better. So that cost, that massive cost that we foresaw in the future has now disappeared.
And then, of course, it starts to get interesting when you start further, Steve, and say, well, how can we make the best of what we've got? And this is where I think the link comes in, when you're making an investment decision with kind of working practices in general, the way you're approaching things. I mean, on the HPC side, for example, I was talking to someone the other day who's got an SLA on HPC with an external provider, it's buying a set amount of processing time. And what they've found over time is that they've been able to make much better use of that because they've started to work with the users and getting them to prepare their jobs in the most efficient way to go on the machines, and therefore they're squeezing more jobs onto a given amount of capacity.
So we're working with a couple of HPC sites at the university where we're actually now going to be perhaps not charging back power to the user as yet, but certainly measuring power at a user level. HPC uses job schedules, so you know when a job starts, you know when it ends, and if you're tracking and you know which machines it's run on. So if you know the power each of these machines is taking and you're sampling that regularly, you can actually charge back the power to each particular job and therefore the departments that need that job. And yes, I've heard this said from the Carbon Trust several times that without a carrot and stick approach, no one wants to reduce their energy costs. You've got to know who's using energy poorly or who's using it well in order to change behaviour. If all you have is my data centre uses 0.5 megawatt of power, that doesn't really give you any useful information. You've got to know who's using the power, who's using it well, who's using it poorly, and therefore who can I put pressure on to make changes. It's rarely the data centre operator or owner or manager that has the decision to tell the chemistry department off or the finance department to make changes. And actually, the issue we find is different stakeholders generally don't want to talk about these things, and actually getting all of the stakeholders together in a room is an important first step to improving the efficiency of your IT. Because unless people are willing to change, you won't be able to improve it that much.
Okay, well, people are drifting off, obviously, it's going to be 1/4 past, so any final comments, questions? No? It's a good note to end on, I think, Michael, bringing stakeholders together. So that's what we've tried to do with finance and IT types, so hopefully it's worked for you. We've certainly found it very interesting, so thanks for coming. Just fill those forms in if you want, particularly on the trade materials side. And see you again, hopefully.